Greetings, fellow mechas. Today we'll be looking at a utility maximization problem. The problem. Paul has a utility function u x1 x2 is equal to x1 3/4 times x2 1/4. The price of x1 is $20 and the price of x2 is $6. Paul's income is $48. First part, part A. Write down the utility maximization problem for Paul. Pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this problem. Let's solve this part of the problem together. So, what is Paul's utility maximization problem? Well, Paul's a utility maximizer, so U is equal to max. And what is he maximizing? Well, he's going to be maximizing x1 and x2. So he's maximizing x1 and x2. And what is this subject to? Well, he's maximizing subject to his budget constraint, which is, so subject to his budget constraint, which is $20 for x1 plus $6 for x2. This has to be less than or equal to his income of $48. So this is the solution for part A. Now, part B. Set up the Lagrangian function for the utility maximization problem. Now pause this video, take a few minutes, and solve this problem. Welcome back. Hopefully you were able to solve this part of the problem. Now let's solve it together. So we're going to set up the Lagrangian function for the utility maximization problem. So we are going to be maximizing with respect to L, should be equal to the utility of x1, x2 minus lambda x1 p1 plus x2 p2 minus m. This is the solution for part B. Now that we got the problem set up for the maximization, let's solve for our first order conditions. So part C, write down the first order conditions under the Lagrangian method. So now pause this video, take a few minutes, and solve this part of the problem. Welcome back. Hopefully you were able to solve this part of the problem. Now, how do we solve for this? Well, we need to take partial derivatives. And what are we taking partial derivatives of? Well, we're taking partial derivatives of our utility function. So, let's take the partial derivative with respect to x1 first. Well, this will be 3/4 x1 minus 1/4 times x2 to the 1/4 is going to be equal to 20 lambda. Now, let's solve for the partial derivative with respect to x2. This gives us 1/4 x1 3/4 times x2 negative 3/4, which is going to be equal to 6 lambda. And finally, let's solve for partial derivative with respect to lambda. This gives us x1 p1 plus x2 p2 is equal to m. So these are our first order conditions under Lagrangian method. Now, for the final part of the problem, how many x1 and x2 does Paul would like to consume? So now pause this video, take a few minutes, and solve this part of the problem. Welcome back. Now, how do we solve this part of the problem? Well, we set our partial derivative of x1 equal to our partial derivative of x2, and then we can solve for either x1 or x2 demand. So let's set this up. So we'll get 3 over 80 x1 negative 1/4 times x2 to the 1/4, which is going to be equal to 1 over 24 x1 to 3/4 times x2 to negative 3/4. So now we need to simplify this. So how do we simplify this? Well, we can times the right hand side by 24. So then we get 24 times 3, which is 72 over 80 x1 negative 1/4 times x2 to the 1/4 is going to be equal to x1 to 3/4 over x2 to 3/4. Now we need to simplify 72 over 80. I don't have a calculator on me. So let's see, we get 40 over 36, 18 over 20, 9 over 10. That's it. 9 over 10. Yep. That's right. So 9 over 10 x1 negative 1/4 times x2 so 1/4 is going to be equal to x1 3/4 over x2 3/4. Okay. So now from here we get to decide to solve for either x1 or x2. Let's solve for our demand for x2. So we'll get 9/10 of, so for x2 we'll get x2 is going to be equal to 10 over 9 x1. And how did we get that? Well, we need to separate our variables, so we times the right hand side of this by x2 3/4 to both sides. This cancels, this becomes x2. Then we need to move this stuff over to the right, so we times it by the reciprocal to 10/9 to cancel that. So 10/9 over here times it by 1/4. This goes over here, this becomes x1. So this is our demand for x2. Now, what do we do with this demand that we get for x2? Well, we plug it into our budget constraint. So, if we remember our budget constraint, we get 20x1 plus 6 over 10 over 9 x1 is going to be equal to 48. So we get 20x1 plus 60 over 9 x1 is going to be equal to 48. And we'll get 20, let's see, this is 6, and that's 54, 6 over 9, so that's 2/3. 2/3 plus 20, so that gives us 26 and 2/3. x1 is going to be equal to 48. So x1 is going to be equal to 48 divided by 26.6, repeating. So that's our demand for x1. And then to find x2's demand, well, we just plug in our value we got for x2 to our x2 demand, which is 10 over 9 times this 48 over 26.6, repeating. So these are solutions for what will Paul consume if he's maximizing his utility. Well, he would like to consume 48 over 26.6 for x1, and for x2 he would like to consume 10 over 9 times 48 over 26.6, repeating. Hopefully this video helped. If it did, please consider subscribing and liking this video. Thank you.